Welcome to Building the Future. I'm your host, Kevin Horick. You can check out new episodes of the show every Tuesday and Thursday at 2 p.m. If you missed an episode or want to get more information about the show, please visit buildingthefutureshow.com. Welcome back to the show. Today we have Cormac Rabbitt. He's the promoter at Metro Dublin. Cormac, welcome to the show.
Thank you, Kevin. It's a pleasure to be with you.
Yeah, I'm excited to have you on the show. Obviously there's a lot of talk about kind of the transportation industry and kind of the, revolution that's probably going to happen in the next, few decades. But maybe before we kind of get into that, let's get to know you a little bit better and start off with where you grew up.
Yeah, I grew up in a small town in the west of Ireland called Galway, on Galway Bay.
Okay.
It's university town and hospital town, so it's quite a dynamic environment to live in.
Okay, and so you went to university. What did you take in university?
I took civil engineering in University College Galway in the National University of Ireland, and then I went on to do a master's in industrial engineering.
Okay, so what got you kind of passionate about engineering kind of early on?
Well, what got me passionate about it, my father was a civil engineer, and as a young child, I travelled the breadth and length of Ireland, with him and looking at various projects. When I was 9, 10, and 11 and 12, I used to accompany him to building sites, and I got all the lore of what's happening in construction. So I had a very deep interest in the whole area of construction and development.
Sure. So walk me through kind of you're out of university. Walk me through kind of your career before you ended up at kind of the Metro Dublin.
Yeah, my career, I spent over 20 years with local authority.
Okay.
Where I was involved in what you call roads and transportation end of roads. There I would have had roads planning control, planning applications for development, then alignment of roads and motorways, and so on. That would have been my responsibility.
Okay, no, very cool. So you're kind of been involved in this industry for a long period of time, and one of the reasons I really wanted to have you on the show was because it seems like so many people are talking about different types of kind of high-speed transportation. You have Elon Musk with the Hyperloop, or building faster trains, or maybe like taking a little kind of aircraft, maybe just leaving the Earth's orbit and just coming back down, just so commute times are just at least doable, where you could maybe fly from New York City to London or something in hours instead of how long it traditionally takes now, or the Hyperloop that Elon Musk has kind of proposed, where it's hours from New York City to LA or something like that. But I'm kind of curious to get your thoughts on kind of the logistics of actually building some of these high-speed kind of transportation systems, because when you and I talked months ago, you had some really interesting kind of thoughts about the challenges of actually building some of this stuff, because it's such heavy infrastructure.
Right. First, I'd say it must be one of the most exciting times to be in transportation, because we're really coming to a wall of change. You just have to look at the motor industry, and the development of diesel engines has virtually stopped because all the money is going into electric engines.
Okay.
I think it's a very hard changeover for the industry. So it takes newcomers in to revolutionize it. The whole basis of, say, the rail industry, what you call is the loading gauge, and it's so restrictive, and the people in the industry are so into the improvements they've made over the years that they find it difficult to leave them behind and take on the new concepts and the new ways. So when you think about it, people like Elon Musk and others have come in, and they don't see all the difficulties and the problems that everybody in the industry have been trying to solve for years and years to get incremental improvements. And he steps outside all of that and he says, look, let's just, speed up tunneling machines, do hyperloops, do this, do that on it. In the beginning, that type of process, you're going to see a lot of, pulling it apart and, impossible to do it this way or that way. But eventually you find ways of doing things. So what I think will happen is that, for a start, they're talking about capsules with 58 people in it, mm-hmm. or less even on it. I mean, if you know anything about transportation, insatiable demand is top priority. Sure. You need to be able to move masses of people, very flexible, and so on. If you take, for example, the French TGV, in 1981, they opened up the route between Lyon to the south of Paris.
Okay.
And within years, it was at capacity. They tried to, speed up the trains with 3-minute intervals, or reduce the gaps. Then kind of the limitations came in with braking systems and so on. So they really they couldn't widen the carriages because the gauge, the loading gauge, what you call it, the width of the train and the clearances would be very, very awkward. So they used a double deck train, and instead of the TGV, they call it the LGV.
Okay.
And they increased the capacity by 45%. Now, I'm just taking that as an example because if you're talking about going from San Francisco to Los Angeles or whatever by high-speed train, transporting 50 people, it's just, you'll never make the numbers, whereas the single LGV train in France would take 350. So, gotcha. That's what 6 times, 7 times more. So that's the type of scenario you need to be considering. I'd also think that you need to be considering, this business of twin tunnels or single tunnels. If you take San Jose at the moment, they're considering using a single large tunnel, what's known as the Barcelona tunnel. Nicola de la Valle is the guy who designed it in Barcelona, and like 2 twin tunnels. If you had a twin tunnel 3 meter diameter, or 3 meter diameter, a 6 meter diameter, 2 twin tunnels 6 meter diameter has the same outer surface area as a single tunnel that is 12 meters diameter.
Okay.
It's quite interesting because the risk in tunneling is proportional to the surface area of the tunnel.
Okay.
More than it is than the diameter of the tunnel. And the logistics of building a tunnel, it's easier to build 1 tunnel than to build 2 tunnels.
Interesting.
Yeah, and if you build 1 large tunnel, the difference between a small tunnel and a large tunnel is you just have to have bigger mechanizations to dig it out, but that's the cheapest part of it. You'll still need 3 or 4 crews to work at 24/7, 7 days a week. But mucking it out is the cheapest part. So, you end up with an area, instead of, if you have 2 3 meter or 2 6 meter diameter tunnels, and you which I said has the same surface area as 1 large tunnel of 12 meters diameter, you have actually 4 times the area within the tunnel to work with.
Right.
So what does that do for you? It solves other problems like how to manage maintenance in the tunnel because you have room to do it, how to get access to emergencies, you have room to do it, how to have safe areas for passengers if something goes wrong, you have room to do it, build special rooms along the tunnel, protected areas and so on. And the speed of tunneling is just as fast with a big tunnel, if not faster. Then it is actually faster than 2 small tunnels because With the small tunnels, you have a lot of subsidiary works building cross passages and so on. Seattle took the same decision to go for a single tunnel instead of dual tunnels. Their dual tunnels were over 11 meters in diameter, whereas the larger tunnel, I think, is around 17 meters in diameter.
Interesting.
But it worked out cheaper. And, just to finish on that, is that a city like Barcelona built their tunnel would have cost twice as much had they built dual tunnels, twin tunnels.
Sure.
Yeah. And I'm assured by experts in the area that that the fire hazard in the smaller single tunnels is much worse. For example, in a city, it can take you 42 minutes to evacuate a single tunnel.
Oh, wow.
You can think of 1,000 people with hardly any room at the side, less than a meter at each side of the train to get out.
Sure.
Or a larger tunnel, which can be evacuated in 12 minutes in the worst circumstances, as compared to 42.
Yeah, it's kind of a no-brainer then, right?
It's a no-brainer, and when you look at the accident records, and it's all about not being able to get access to the tunnels for the rescuers or for the people to get out. You could take the Channel Tunnel, for example. There's a twin tunnels in that, and there's a tunnel in the centre, and everybody says, great, we have a tunnel in the centre, everybody got out. Yeah, but it nearly killed everybody. Why? Because all the ventilation systems were all going in the wrong direction. So it's virtually impossible to control such a multifaceted ventilation systems that you have with twin tunnels. As a single tunnel, you only have a fraction of the interfaces.
Sure.
For your airflow and so on. Yeah.
So depending on how long you are kind of underground for, at what point do you have to maybe potentially start really building a really good ventilation system? Or is it pretty much no matter how big or small it is, you need to start, kind of pumping in oxygen or figuring out some sort of ventilation system? How big?
Yeah. Well, that's the major problem not being faced up to by Elon Musk and so on. They kind of think smaller tunnels are quicker and easier to build. That's not the case. The ventilation system, you have to have emergency access and egress from tunnels. Okay. So you have to have ventilation shafts built at very regular intervals. With the larger tunnel, you can have the escape exits built within the tunnel, so you can have much longer between ventilation shafts, because you have much bigger areas to pump in air and extract air with it, which was in the larger tunnel.
Okay. Interesting. So, yeah, because I guess, because if you're trapped in like a little capsule or something, they would have to be pumping in oxygen or something, right?
Well, it'd always be air, Now, if you go scuba diving and you have oxygen and nitrogen, and you go down to a depth, the oxygen compresses more than the nitrogen, so people get the narcosis. What we call it here, because of the bubbles in your blood, and that's due to the nitrogen being in it. Now, I don't know the dynamics of the opposite when you go to a lower pressure, but the resistance to movement is proportional to the cube of the air density. Okay. So if you can get the air density, the number of kilograms per cubic meter, if you can get that down from say 1.24 kilograms per cubic meter, which is at atmospheric, to down to half of that, you're going to reduce the resistance to transport moving in a tunnel by a huge amount.
Yeah, okay. That's interesting. So I'm curious then, obviously going above ground is cheaper than going underground, correct?
Not necessarily so.
Okay.
You take, in nowadays, if you have a tunnel and you're talking about an incremental length, once you've got the tunnel boring machine going. Mm-hmm. Now, I'd assume that you would have a separate tunnel boring machine for every 5 or between 7 and 15 kilometers.
Okay.
So you would be able to launch if you had 100 kilometers, you'd launch maybe 12 tunnel boring machines along the route.
Right.
So you could build it. They would take a specific period to build it, but it could all be done at the same time. And if one tunnel boring machine fails, you bring the one behind it or in front of it back in the other direction to complete it, to complete the one that failed, and so on. Your question there was, sorry, about to build underground, cut and cover, or on surface or over surface.
Sure.
How does it compare? Well, basically, to compare it is that, give you an example, in Madrid, in line 12, the Metro Sur, the South Metro, one section of it was cut and cover, and that delayed the whole project by 4 months.
Oh, wow.
So you had an enormous project of 40 kilometers of tunnel and metro system delayed 4 months. That's a huge amount of money signed in redundant for 4 months.
Sure.
There's no cash flowing. You don't have control of your environment as much, and you're into disturbances and so on. Like tunnel boring machines are so sophisticated now. You can have what's known as double shield tunnels, which is kind of each shield is a new safety level in front of it. You can have high pressure tunnels, and the front of them is higher pressure with foam injected out in front of them to stabilize the ground and pressurize the ground before the tunnel approaches the ground. So if you set up a tunnel and the incremental amount per kilometer is actually quite small, and the tunneling part, the stations is the expensive part. 2/3 of in a city is to do with stations.
Okay, interesting.
Like the civils would be about 75% of your overall cost, and 2/3 of that is your stations.
Okay.
So if you can save something by building stations better and cheaper, which we propose to do in Dublin, we've taken out a patent on a station where the platforms are offset from each other. Instead of being one on top of the other vertically, we've offset them we've offset them one to one side and down. So we've offset them both horizontally and vertically with each other, and the same with platforms. So you'd have a platform on top of a rail line and a rail line on top of a platform.
Oh,
so that gives you a whole different dynamics in tunnels. To build stations and to build wide platforms in smaller tunnels. For example, instead of maybe a 4-meter platform like you got in Barcelona, you would get maybe a 6.5-meter platform in that layout.
Oh, interesting. Okay.
Interesting, yeah. And it also allows you that would save an immense amount of money in building stations.
Sure.
And construction time, because the construction time is in building the stations, not in building the tunnel.
Oh, interesting. I never would have guessed that.
Yeah. Like if you take Madrid, they would have had to order a tunnel boring machine, which would have taken 11, 12 months to order and to set up.
Right.
But in that time, you really have to build your launch pad anyway, so it's going to take you that time.
Sure.
And you might have to build 5 or 6 launch pads.
Sure.
At that time. And which happened in Metro Sur, 40 kilometers. They had 6 launch pads, or 6. They had probably 5 launch pads, and one section was cut and covered. So your tunnel boring machine has been bought and set up. Your tunnel boring machine will be through all the stations before the stations are finished.
Interesting.
Yeah,
okay.
and yeah.
No, that's interesting to me. So I'm curious, what are some of the kind of challenges you guys are currently facing in Dublin with the metro system there?
From the engineering, very little really, because the ground conditions are excellent for tunnelling in Dublin. We have a limestone, which is very suitable for tunnelling. The challenges really are could I say bureaucracy?
Okay, sure. No, fair.
Which we don't mind. But it's really that would be the major challenges. Like almost 20 years ago, I brought in the Japanese consortium to actually offer to build a full metro system for Dublin.
Okay.
And that initiated the whole process. But since then, between economic collapse and wanting to go back to old methods of contract, the thing has been delayed and postponed on it. And unfortunately, Dublin, like many other cities, is an absolute traffic meltdown
Sure.
on it. And as we see, the biggest challenge is that doing something incrementally is of little benefit to the city, because the city is growing faster.
Sure.
If you only take care of one area, you really do very little for the city as a whole.
Sure.
So you need to do a transformational change in transport that integrates with all the other modes of transport as well. And that's what we're trying to do. And we're quite advanced with it. We're hoping to kick off within the next couple of months, and we will build it extremely fast, because we've looked at the best practice in the world. We've looked at the best people in the world who have constructed tunnels most successfully, and we're following their procedures of doing it, all within the current legislation and contracts that we use here in Dublin. We're not inventing any wheels, or we're not we're using proven methodologies and so on.
Sure. So is that a lot of the stuff taken from kind of the Japanese, or what kind of parts of the world have you guys kind of taken ideas and things that have worked from, or is there kind of one main kind of country, or is it kind of just spread out?
It's fairly spread out. Um, it's there's a few pockets here and there of very good contract methods.
Okay.
How the risk is shared, which there's a great reluctance for governments to take on board, because it's something new. So where have we looked at? Well, basically we'll be building, using Irish methods and Irish so on and so forth. But we've looked at the contract methods used in Madrid, which really was a management of the variances in a contract, where the risk was like two levels of contract. One was to build between A and B, say about 5 or 6 kilometres. The risk was totally taken by the employer, but they set up a whole subsidiary method of managing variances in the contract. So when issues arose, they dealt with them immediately. There was nobody looking back on drawings, trying to defend drawings. They were just trying to find solutions the whole way through. So they did about 20 or 30 different things in the contracts, like ring fencing the money, paying the contractor in time, and so on. So they built extremely fast and extremely cheap. On a technological end, they used what would be considered at the time was tunnel boring machines that had 2 or 3 times the power necessary to build the tunnel.
Okay.
Because they didn't want it to fail.
Sure.
The machine to slow down. The same with other equipment. They took a whole lot of initiatives like that on it, and how they integrated different contracts, and how if they had a line of, like, take the 40-kilometre line, all underground, how they integrated those. They were very aware and did it very well. So, the cost of and the time of all of tunneling and all that is down to how you manage your contracts, and how you manage the risk within that, and how you ring fence your finance, and how you give control to 3 people: a bureaucrat, a technical person, and a good administrator, and maybe somebody who's got political, can weigh up the political decisions very quickly.
Sure. So I'm curious then, how do you, because obviously it probably takes years before, from kind of the day you start planning to it actually being finished, how do you think about the technology, or because obviously they have faster, and better technology from the day you start to kind of when it's finished, because it takes years. How do you guys kind of plan for that kind of almost like future proofing is maybe the wrong word for it, but I can't really think of anything else for it. But so it's still kind of fresh and new when it actually is live and ready for people to use.
Yeah, it's not that difficult, really. You know, basically, you can have a metro line and it can be standalone.
Okay.
Because it's not integrated with other systems. But really, you want everything to be, have the same gauge, the same width of carriage, and the same clearances, and so on. And that's kind of why I think that the Hyperloop, that you really need to consider larger trains, and you need to consider a different type of tunnel, say for bringing containers from San Francisco from the Bay inland to a dry port or something. But how do you deal with the step change in technology? That I think we're very embedded with what's there already. Like integrating rail lines, you're moving massive weights, and you have to be, and the gaps you need between them, and so on, get very complex very quickly.
Sure.
And people say, okay, we'll have all these small cars buzzing around the place, and so on and so forth. But if you're talking about a city, you really have to talk about an extensive transportation system, and how it integrates with the other systems, because the bigger system is like a beast. You feed the beast, and then the beast, does the kill, but the beast then feeds all the other animals, that come along and chase it away or whatever.
Sure.
So it's all part of a system. Now, one of the big problems is you have people comparing, buses and rail and so on, and walking and cycling. That should never be the case. It should be, if a system is good, it's good because it's good. It's not good because some other system is bad. And if you take any development of a lot of cities, you take, two good cities to look at would be Vienna and Milan. Okay. They have a network like a net, or like a web. You've got a tram system and you've got a rail system, and the stations can, feed lines in different directions. But what's interesting about those cities, is particularly like Vienna, is that they took the trams out of the city centre. Just, it's kind of a square mile, and the trams come 200 meters within that square mile. But they only have cross lines through the city, and kind of a circular tram line around, and lines come in to a city tangentially and go out in another line. But what's interesting in Vienna to me is that they made all the mistakes you can possibly make with transport. But eventually in the mid 70s, or the early 70s, they were building a supertrans system with parts of it underground in the city centre, and they had 2/3 of it built, and they realised it was wrong. They ripped it out the trams, made the tunnel a bit bigger, put in a metro, and they have one of the highest uses of public transportation in the world, one of the most successful. And what you find out from that is that, and Milan, is that the amount of people that use public transport is not so much down to density, it's down to the geography of the network that you lay out. It's very obvious when you think about it. If you go to a station and a train, you can go in either direction, but if there's two lines crossing each other, you've got 4 directions to go to. So you're not just twice as likely to go to the station, you're probably 3 times as likely to go to the station. So if you can complete your journey by rail, and you've got good options to do it and a proper system to do it, you're likely to use it. So that would be Vienna and Milan for you, and some other cities.
So have you found, though, that, say it takes me, I don't know, a 30-minute commute by car, but it takes me, an hour or maybe an hour and a half on like public transit. Is there like a sweet spot where people are willing to say, well, I'd maybe take, public transit if it takes me just like, 15 minutes longer than the car, or is it double, or is it kind of like it needs to be pretty close to how long it takes them to drive, or how have you found that over the years working in the industry?
Well, thinking about it, it's all about the sweet spot.
Okay.
Like you just divided up transport into all the different forms there. But instead of basing it on the mode of transport, consider just the individual. And the individual just thinks, me, I want to get from A to B.
Sure.
1 minute you're cycling, sometimes you're walking. You could be in a car, on a motorbike, or a bus, or a train. But it's only the one movement. Now, I did a survey in the west of Ireland, city in Galway, where I grew up, and from all the questionnaires, I just found that people didn't care about what mode of transport. They just wanted transport,
Sure.
And it was very interesting. So integrating, park and ride, and it means that you would set up your how you deal with transport in a totally different way. From the individual's point of view, not from in this mode and that mode on it.
Okay.
So that would leave you much more flexible. Now, most of the systems that are built they're old, and they're not efficient. You look at interchanges on motorways, most of them are terribly badly laid out.
Yep.
And so on. Now, same with transportation system, but that doesn't particularly matter. You've just got to make incremental improvements. Like London has been trying to undo the mistakes they made with the metro going back generations. They didn't connect up the trains across the city, so the train lines that came in could discharge hundreds and hundreds of people, but the metro stations that were at the top of them could hardly carry the number of people. So you need to kind of step back and almost redesign on it, and not be afraid to redo it. Like if you look at Madrid, they rebuilt most of their metro lines in the last 2 decades.
Interesting.
Yeah, and doubled the amount of metro lines they have in that time as well.
Okay. No, that's actually quite fascinating. And do you find part of it is, maybe mistakes they made in the past, or is part of it also just how we kind of live our lives and we're more on the go now more than we were before, or is it kind of pretty similar to where it was maybe 3 or 4 decades ago?
I think there's a lot of similarities.
Okay.
I think this business of mistakes is overemphasized. If you take a child getting up and walking, they fall over all the time. They make every mistake, and you tell them to get up and walk proper. You try and direct them, but
Sure.
they'll still fall over. But there's advantages of falling over. You learn your balance. So when you grow up, you're not clumsy.
Sure.
If you crawl and all that first. It's the same with a city. You have to go through the different forms, of transport. There's no right form. There's what they do in Vienna, which I was describing. They say, well, trams work well here, metro works well here, buses work well here. Each where each is strongest.
Right.
Cycling works well here, but it's not so much that one is good and one is bad. It's it's a mix and match, and that's the way life is. So. And that's the way we are. You could be out there pushing a child in I don't know, you call them in buggies, or we call them,
sure. Yeah.
Pushchair.
Stroller. Yeah.
Yeah.
Same thing. Yeah.
Yeah. You could be stroller. You could be out there 1 minute or in the afternoon pushing a stroller, and 2 hours later you could be cycling, and an hour later you could be in a car, or on a bus. So you're all of these things, and it needs to go back to the individual. So your question about, the sweet point is that people work around systems, to optimize the best way they can find for them. So I think that's all these kind of solutions of busways and cycling is great. Like I remember China, that hundreds of thousands of bicycles, it wasn't great, you know. It
Sure.
wasn't heaven. So to try and get to hundreds of thousands of bicycles in your city, you know, but it might be good to have a lot of cyclists. It's not a solution. It's not a solution for everybody. And you know, I think, you know, with self-driving cars and so on, if you have a good metro system and shared cars and all of that, it's all part of an integrated bunch between taxis and lift sharing and you name it. It's a matter of matching everything together, you know.
Sure. No, that's actually a really interesting point and makes a lot of sense. And I think the thing that got me kind of thinking about this as we're talking is you're right. Like the self-driving car is potentially just another component to this. And to your point about cycling, like obviously if you live in kind of a cold, maybe snowy climate, well, you're not going to cycle, right? Or you're not going to get majority of the population to cycle, you know, during those cold winter months. Like I used to work with a guy and we get snow here where I'm from. And so he used to ride his bike to work every day, no matter how cold and snowy it was. But he's in such a tiny minority of people that are willing to bike in those conditions. So to your point about having kind of different things, even just based on the climate you live in is huge, right? And optimizing for the geographical region that you're in.
Yeah, and he's a particular physique, and he's at a particular time in his life, so it suits him.
Yeah, sure. Yeah.
You know, I mean, you basically you should look at transport. You should look at what's the proper thing to do. You stop looking at going down down the track of, you know, you build it because you don't build rail system because people haven't got cars. You build it because you want to give access to people.
Sure.
You know, and a way of life. And you know how tied up it is with, you know, people who have a long distance to commute to work will describe their work as bad, and people who have a short distance to commute will be much happier at work.
Yeah.
But like, I mean, that could be you for 2 or 3 years, and then you're gone to some other place, and you could be commuting an hour again, you know, and vice versa. So I think it's time we approached what needs to be done with imagination and let people out there do it. You know, we've had great builders in the past, and there are some builders there now that are as good as anybody, if not better than in the past.
Sure.
And I mean, that's, you know, we're seeing a transformation of transport, you know, with new rocket engines, and that's going to lead to planes that shoot up into the stratosphere and go from the US to Australia, you know, because why? They've more powerful engines than they had 20 years ago. You know, it's going to be less of a bother to do it.
Sure.
Design, it's not such an obstacle now as it was even 10 years ago, you know.
No, totally. Yeah, that makes a lot of sense. And then as it gets cheaper just for kind of everyday person to afford it, right? Kind of like air travel. Now, most people, if they want to take a plane ride somewhere, you know, if they save for a period of time, they could do it, right? Where, like, I know I think for the super rich right now, you can pay to go up in space or something, right? And it's, you know, millions of dollars or something to do that. And obviously only a select few of the population could afford to do that, right? So as it kind of comes down in cost and price, you know, air travel to, you know, or faster air travel, whether you leave the atmosphere or not, is going to only come down in price. That's interesting.
Yeah, yes. I mean, travel, it brings such benefits to people, but it also, you know, we get great value from it because all the goods we buy are transported,
sure,
you know, long distances. Now, that's not something new. I mean, goods being transported long distance has been going on for hundreds of years.
Sure.
In mega quantities, you know, if anybody cares to look at the amount of wheat moved from the Central States via the Great Lakes to Europe, you know, in the 1800s, it was huge.
Sure. It just
you
took
know,
longer,
and
right?
so on. It took longer, but they had fairly sophisticated steamships, you know.
Sure.
And so on, you know. It didn't take that long. They had fairly refined. And like even 1,000 years ago, you could buy anything from all parts of the world in markets,
Yeah, that's really cool.
Very extensive. So it's not new. It's something that's ongoing. Only now the population is bigger, but the amount of transport is proportionally bigger.
Sure, and I guess it just kind of seems that it's more in the media lately, right, over the last couple years, because people are pitching these kind of grand ideas, right, that are getting huge kind of media publicity.
Yeah, yeah. And some of the ideas are, well, if you take a atmospheric tube or tunnel, and lower the pressure, you're going to um, reduce the energy consumption hugely, which is very, very welcome.
Sure.
So there's great benefit from going down these paths. But when you go down these paths, you're going to really have to, yeah, you're going to have your train in a tunnel. And your train in the tunnel is going to have all the safety features you can think of and more.
Sure.
And you don't want the train going at supersonic speed through your neighborhood. But if it's in a low atmospheric tunnel, it's not going to make any noise.
Right.
And do you build that on the surface or underground? Well, if you can do, say, 4 meters an hour or something in a tunnel boring machine, you're going to cover a hell of a lot of distance in a year.
Sure.
with a few tunnel boring machines. And that's quite easily it is achievable. They've done it many, many, many times, that average, over a year and more. So it's quite doable. So I know a lot of the talk about is that some of these ideas are way out. Yes, they are. And people who are in the industry know all the problems, and they're right because they know the problems, and what they talk about is right. But there's other methods and solutions that arise from the people who are pushing the limits, who are pushing the limits forward.
Sure.
But it's very, very difficult for the industry to take it on board. Why? Because you have the vested interests. Like to protect their patch, and that's their job, to have secure systems that work. But they're going to be left behind so far. Within a few years, it's like the iPhone came in 10 years ago. And
sure.
You can't imagine what life is like without it. Well, same in transport. We're getting new materials. We're getting new processes. We've already got a lot of the process that need to be used. It's just a matter of putting them together.
No, totally. That makes a lot of sense. So we're coming to the end of the show. So let's close with maybe mentioning where people can get more information about yourself and, anything else that you want to mention.
Well, more information on myself. I have a website now. It's probably the worst website in the world, metrodublin.ie.
Okay.
IE is Ireland, IE. About myself, just email me. What I'm at the moment is we want to build an extensive metro system in Dublin of about 90 kilometres. Dublin doesn't have a rapid transit system at the moment. We have what's called a Dublin area rapid transit system that goes along the coast, but the frequency of the trains is so low and the trains are so slow. You couldn't count it as a rapid transit system. We have an airport in Dublin that's carrying, I think it was 27 million passengers last year, and doesn't have a rail connection to it. It's actually the second busiest international airport in the world. The Dublin-London route is the second busiest international route in the world, after Taipei, I think, in China is the one before that.
Interesting.
But we have a very dynamic economy. That we're coming to a stagnation where our road is blocking almost every second day, or the major arteries in Dublin, the whole motorway around Dublin. Dublin is like Boston. It's a similar area and size with a ring motorway and a few radial routes into it. But Dublin clogs up off peak time. every other day. So something dramatic has to be done, and I'm prepared to do it. I'm at the basis of seed financing, or seed funding, I should say.
Sure.
And we want to build 90 kilometres. About 27 of that is upgrading existing lines. We need to upgrade existing lines because we need critical mass in our transportation system to generate customers, so people have choice. You need, like I've said, you need a comprehensive system for transformational change. And we can do that. We have the plan, we have the methodology, we have the people, we have the expertise on board. We're just waiting to write some of the. We have the legislation in place. We're empowered by legislation to do what we need to do. But we're just getting to the starting block. The last 6 months, and I can't see it getting to the starting block for another 3 months. So I'm with time slippages. I'm kind of saying, where are we going?
Sure. No, that's interesting. Well, Cormac, I really appreciate you taking the time out of your day to be on the show, and I look forward to keeping in touch with you, and have a good rest of your night.
Thanks very much, Kevin. It was lovely talking to you.
Thanks. We'll talk soon.
Here you go.
Bye. Thanks for listening. The music for the show is done by Electric Mantra. You can check them out at electricmantra.com and keep building the future.